Okay, on this video, we're going to talk about the last three possible types of chemical reactions. Okay, these notes start on page 190. The first one that we're going to talk about today is a single replacement reaction. Okay, so a single replacement reaction is where one element trades places in a reaction. Okay, so this is where elements trade places in a reaction. Okay, so you can have an element plus an ionic compound comes in and kicks out a less attractive element, and then it creates a new ionic compound. Okay, now in these chemical reactions, this one is talking about an ionic compound, but we also need to remember that water can also act like an ionic compound. So water is H2O, okay, but we can kind of think of it as like hydrogen hydroxide, and that's how water is going to act like an ionic compound here. So in a single replacement reaction, metals will replace metals, and nonmetals will replace nonmetals in a displacement reaction, okay? So let's look at a few examples here. So in the first example, now we can also have metals replace hydrogen. And that's where I was talking about, this is when we have water, we can kind of think of it like this. So for example, if we have potassium and water, if we think of water like this, what ends up happening is potassium comes in, kicks hydrogen out, and then hydrogen is by itself, but you have to remember that hydrogen is our H in Hofbrinkel, which means it's going to be written as a diatomic, okay? Which then means potassium has a +1 charge, hydroxide has a -1 charge, therefore potassium hydroxide would just be KOH, okay? Now these reactions are really easy to identify because you look for one single thing on one side, on the reactant side of the reaction, and something single or by itself on the product side of the reaction. Okay, and then as always, you need to make sure that the chemical reaction is balanced. Okay, so here I have one potassium, two hydrogens, three hydrogens, one oxygen, one oxygen. So I'm going to make my hydrogens equal by putting a 2 here. So now I have 4 hydrogens. I'm going to put a 2 here and a 2 here, and I should be good to go. Okay, the next example is a nonmetal replacing a nonmetal. Okay, now here, we need to realize single element. So what's happening is fluorine is coming in and kicking chlorine out of the reaction. So then I have Cl2 on the product side, and fluorine is now in a reaction with aluminum. Okay? So then the last thing we would need to do is balance. So 2 fluorines, 3, so I need to put 2 here to make it 6. 3, so 2, 3. Okay? Whoops, that is not right. Sorry, this should be 3. This should be 2. Okay? The last one I want you to balance, but I want to talk about why it's a single replacement reaction. In this reaction, we have single on the reactant, single on the product. So this is going to be a metal replacing a metal. So copper comes in, is more attractive than silver, so it kicks silver out. So on this side, silver is by itself, making it a single replacement reaction. Okay, so that's the first reaction. The second reaction is a double replacement reaction. Okay? And in a double replacement reaction, what's happening here is we have ionic compounds. So you have to remember that an ionic compound is a metal plus a nonmetal. Okay? So we can think of this as as sort of like what's happening here is that the ionic compounds break apart and then the metals switch partners. Okay? Switch anions. So cations and anions are switching partners. Okay? So let's look at some examples down here. And one way that I like to identify these reactions is I say there's a lot of stuff going on, right? So if it looks like there's a ton of stuff, or more likely you can say, are there 2 ionic compounds on both, are there 4 ionic compounds total? Then more than likely it's a double replacement reaction, right? So here I can say metal, nonmetal, metal, nonmetal, metal, nonmetal, metal, nonmetal, which means that this is going to be 4 ionic compounds, which means it's a double replacement reaction. Okay, and what's happening here, calcium is going to be partnered up with nitrate, and silver is going to be partnered up with chlorine. Okay, and that's exactly what we see on this side. We see silver and chlorine, and calcium and nitrate. And this is going to be the double replacement, so a double metal replacement. And then as always, you need to make sure that it's balanced. So I have 1 calcium, 1 calcium, 2 chlorines, 1 chlorine, so I need to put a 2 here. 1 silver, 2 silvers, so I need to put a 2 here. 2 nitrogens, 2 nitrogens, 6 oxygens, 6 oxygens, so it's balanced. Okay, let's look at one more example, and then I want you to balance number 3 by yourself. So what's happening here is sodium and sulfate are becoming partners, and iron and hydroxide are becoming partners. So then we have iron hydroxide and sodium sulfate. And then the last thing you need to make sure that you do is balance by putting a 2 here, and that should be good. Yep, and then I should be balanced. Okay, so go ahead and balance number 3. And then our last type of chemical reaction, which makes our 5th chemical reaction, is a combustion reaction. Okay, and a combustion reaction, this is when things explode or blow up. Okay, and these things deal with hydrocarbons, which means we have C and H, and this time we'll just have multiple of these. Okay, so in this example, oxygen must be a reactant because we need oxygen present in order for a combustion reaction to occur. And always carbon dioxide and water will always, always, always be the products. So we'll always have this CH plus this O2 creating carbon dioxide and water as the product. Okay, so let's look at some examples. These guys tend to be a little bit more difficult to balance, but I'm going to show you a trick to kind of help you out. Okay, the first one is the combustion of wax. Okay, so we have our hydrocarbon, which is we have 22 carbons and 46 hydrogens, plus O2 making carbon dioxide and water. Now, oxygen shows up by itself, so we'll balance oxygen last. So let's start with carbon, moving left to right. So 22 carbons, so I need to put 22 carbons here. 46 hydrogens, 2 hydrogens, so I need to ask myself, what times 2 gives me 46? And the answer to that is 23. And then the last thing is oxygen. So I have to say 2 times 2 is 44, plus 23 times 1 is 23. So this is going to be equal to 67 oxygens. Okay, now here's the trick. I always say, what times 2 gives me 67, okay? So you can either plug this into your calculator and say 67 divided by 2. The answer to that question is going to be 33.5. Now, we cannot have a decimal coefficient. In order to make 0.5 a whole number, you must remember that 0.5 is just 1/2. So we can just multiply 0.5 by 2 to get 67. So 67 is going to be the coefficient for oxygen. However, whatever I do to one coefficient, I have to do it to all of them. So with that being said, there's a 1 here, so I have to say times 2, so this becomes a 2 coefficient. I have 22 here, so I have to say times 2, which becomes a 44 coefficient. 23 times 2, this becomes a 46 coefficient. So the coefficients in this balanced chemical reaction is going to be 2, 67, 44, 46, and it's balanced. Okay? Let's look at another example. Combustion of ethane. Ethane is C2H46 plus oxygen, because that's what we need in order for it to combust, and we're creating CO2 and H2O. Okay? So let's start with carbons. So 2 carbons, 2 carbons. 6 oxygens, so 3 needs to go here to make 6. 2 times 4, or 2 times 2 is 4, plus 3 is 7. So you say to yourself, what times 2 gives me 7? And hopefully in your mind you're saying 3.5. Okay? However, you know that you can't have a 0.5 coefficient, so what do you have to do? Multiply it by 2. So you're going to have 7, but I have to multiply everybody by 2. So I'm going to say times 2 is going to give me 2. Times 2 is going to give me 4. Times 2 is going to give me 6. So my coefficients here are 2, 7, 4, 6. Okay? So go ahead and try this last one by yourself, and we'll check it tomorrow in class. Thanks, guys.